come up here and complain for like 45 minutes, so that's one of the things. It should be fun. Okay, so before I complain, I have to give you a little bit of background about what I do or what we do on Chrome. So, for a little bit of context, here's the hows, the whys, the whats, etc. First big question: why does Google actually really care about web security? Now, from my perspective, it comes down to 3 major reasons. So, Google really lives and dies on the web. The truth is that we make overwhelmingly the majority of our money from advertising, cloud services, etc. And almost all of that is getting funneled in through the web. So, or specifically the browser. So it's really important that at least that people have a sense of security, people feel that's reasonably safe, because otherwise it will go away and we don't get paid, and I like to actually get paid. So the next big one is actually Operation Aurora. I'm sure there are a number of you out here who remember this. It's publicly known as Operation Aurora. It was actually Symantec who gave it that name. But this is back in 2009 when Chinese hackers broke into Google. They were specifically state-sponsored hackers, and they had more internal network. And this actually ended up being a huge wake-up call for us. I mean, a bunch of people use this as a punchline for a joke about, now every compromise is an APT. But for Google, it had a really strong internal effect. We looked at it, and like I was the new guy at the time. I got drafted into the response team for the project, and I actually wound up sitting next to Sergey Brin, founder of Google, every day for weeks at a time, because this got him that hope about security. And that actually caused a significant change the way most of the rest of the security was doing. And so the other piece is, well, on Chrome, we're a bunch of open source things. I mean, Google's a weird place, lots of different product areas, people approach things wildly differently, depending on where they are, and Chrome really is the hippie way. People believe in the web as an ecosystem. They believe in this notion of, we can move the whole thing forward, we can make the web better. It's actually something that plays out reasonably well. We do a lot with standard bodies, we try out a lot of things, and security is just one of the areas that we really try to push. So then the next question to answer is why I think browser security is so tough, since I've been banging my head at this for about a decade now. There are a lot of different things at play. First, the fact that on Chrome in particular, we have to deal with a diverse array of platforms. And that makes security a particularly tricky bit, because if you're the native browser, there are certain expectations you can have, certain things you can change. If you're busy trying to support the same browser on a whole lot of different platforms, you're just trying to make it all sort of fit together and show the same basic picture to the next layer. On top of that, we deal with all sorts of insanity, OEM, third-party code issues, which I will actually be complaining a lot more about later. Now, we have the diversity of the platforms, but we also have a diversity of constituencies, which is, the browser's a weird thing. You have a lot of different constituencies. You have your developers you're trying to serve, you have your users you're trying to serve, but you're also dealing with standard bodies, which is something that's somewhat unique to the web platform. And on top of that, we all actually have our own employers. They have their own goals, their own agendas. So we have to figure out how that all fits together. And a very weird quirk of the web is there's even a web standard published explaining what the correct priority of constituencies is supposed to be, because that's just something they felt the need to document. And I guess it goes back to open source code. The next thing that adds a lot of complexity is the competition that you have on the web. So, I said earlier, it's a big revenue funnel. What that means is there's a lot of people competing to control that revenue funnel. And the truth is that browsers are just a commodity. We all support the same open standards, we're all running on the same open web, we all do the same basic thing. The cost of switching is very low, the user demands are actually fairly high, and the truth is that users just really don't understand security as a criteria, so it's not something they're really going to be, that's going to be influencing their decision when they end up on the browser. It's really decide the browser they're using. And then we start to get into the fun details like the attack surface. I can't actually imagine anything more attack surface than a web browser. So you have the problem where most of the existing features, they were designed in the 19, if they were designed, they came in the 1990s. People didn't have security in mind. There was really no notion of how they were going to address these things. And once you ship that stuff, it takes you years to get rid of it. So we're dealing with that while we're constantly dealing with an onslaught of new feature proposals and new things coming down the pipe because there's always a demand for more. And back to the whole issue of being fiercely competitive, everybody's trying to eke it out with performance, so there's a lot of less than safe approaches that creep in the name, trying to get the most performance that you can. So we're trying to balance all of these things together. And then last but not least is the web is really just a beautiful exploitation platform. Well, exploitation target, I should say. We pretty much give you all the primitives that you need. I mean, if you want to stay inside the content frame, there's all the service for XSS and XSRF and all the sort of origin bypasses and everything else. But then if you want to get into memory corruption, we give you your own Tory complete memory language, so you can set everything up the way you like. And we give you raw gadgets galore, because these things are just giant pieces with tons of code in them. And then we give you lots of nice low-level derivatives, like we give you array buffers, we give you canvases. I mean, we're pretty much just laying the whole spread out there for you. And that takes me to, basically, how do we deal with all of this? So, on Chrome, we pretty much have three main strategies that we take for security. And we hit them really in this order. Everybody at this point is probably aware that sandboxing is the big thing that we focus on. So we view it as our strongest line of defense. Isolation in general is our strongest line of defense. It's the number one thing that we do. Now, that's something we keep building on, we're improving it, we're expanding it, we're refining it. You may have heard about site isolation, where by the end of this year, we'll actually be binding web origins to the process level sandbox as an extra layer of defense. And then we have the various standards bodies work that we do, CSP, and other things to isolate the content better within the site. But the main thing is that this is what we're investing most in, which arguably differs from other browsers. The next is the mitigations. I know that Halvar and I have had interesting talks about this. I believe he refers to them as simply a waste of time. But our take is that they have some use. So we try to feather right in. If they don't add significant code complexity, if they don't add significant performance overhead, then we keep. So we have ASLR and dev, those are basically freebies. We have various niche mitigations, stuff like UAF has been historically a massive problem in browsers, particularly .UAF. So we have our .UC, we have partition malloc, so lots of things to get out in front of this. We also have a lot of investment right now going on in client CFI. I'm not sure if you're familiar with it, but it's the control flow integrity. We're already shipping it on Linux. We have this crazy moonshot goal in the next 3 years trying to build some sort of memory safe-ish inner sandbox sort of thing. But in the end, this is still really our second tier, and we're just trying to get what we can get cheap. And then finally, we have anti-abuse, which I really have almost no technical interest in. It's the phishing stuff, the download stuff. It's actually really important. It's the stuff that most people get compromised with. But I think everyone here agrees that it's just not the fun stuff. That said, it is something we have to invest in. It is something that is critically important. So we have things like safe browsing, due to blacklisted dangerous downloads, blacklisted malicious sites, and that we're increasingly trying to move things more to a gray list, or even potentially someday a whitelist on those fronts, at least for downloads. There's a lot of work now going into phishing because this is more of a trackable problem. We're moving more on things that do origin-bound credentials, things that keep users from entering passwords. Just basically, we want to try to take this one off the table, and that's probably possible in the next few years. There's also a ton of work going into phishing detection because you have to know what's out there. So those are our major approaches. Then the question is what we get from Google. So Google has a lot of resources, it turns out. One thing Google's really great at is compute. And so we kind of use that. I know that a few years ago, someone came to Infiltrate, gave a presentation on cluster fuzz. That's our distributed fuzzing infrastructure. Runs thousands of cores over at least half a dozen different platforms, and probably they're counting at this point as it keeps growing. It's nice because it's integrated into our build process, our waterfall structure, even our release process at this point when people want to launch new features. If they touch hostile accounts on content, then they actually have to write a fuzzer for it. And with work that people like Michael Schuh and I have done, we're increasingly getting, generative fuzzing, better guided fuzzing, we're getting code coverage in that. We've gotten a lot of mileage out of it. It's something that we just keep investing in, which we can do because we get a lot of compute. We've also recently rolled out OSS Fuzz for major open source projects, kind of critical infrastructure stuff, just as, to help the community. Now, the next big thing we get from Google is the interesting mix of threat intelligence. So, Project Aurora, Operation Aurora, was an eye-opener, I said, and in many ways it showed us that we actually have a lot of great threat intelligence capabilities at Google. It's shocking that Google would have a lot of visibility into these sorts of things. And that has actually worked out really well. So a lot of the Aurora team actually stayed over and stayed behind after the incident was done to spin up a permanent threat intelligence capability. We find that very useful in conjunction with the Project Zero people as well, giving us real hands-on information on exploits, what to look for. All of that together gives us a lot of insight into things like we actually get 0 days in the wild that impact Chrome. There are always Flash, but we get them, which is nice. We have a lot of we get common attack patterns, stuff that feeds back more into anti-abuse. But we also get a lot of useful information for long-term security strategies, standards development, etc. So it's a nice thing to have. And then one of the really useful things that we get out of Google is we get to do crazy things at scale. So I'm not sure how many people are familiar with HTTP2, but that was something that grew out of one of our crazy things at scale, which was we were playing around with something we called Speedy, eventually evolved into the replacement for HTTP. We can do these kinds of things because we actually own the most popular browser on the internet, and we own the most visited site on the internet. So you can actually muck with these things, try out things no one has, various different experiments. Some of them are just one-off hacks. There's also some of them are very forward-thinking. Adam Langdon is currently mucking around with post-quantum crypto. He's always tweaking things with elliptic curve crypto. And then some of them don't pan out. One of my favorites was TLS False Start, which had the perfect name for something that we were going to end up killing. But in the end, we try things out, we see what works. And if it works, we try to push it out, ideally into a standard, get it out to the median. So now that I've given you all this background, it's time for me to actually do what I came to do, which is complain. Complain about the stuff that I actually worry about and get frustrated by the most. And for me, it comes down to what I call friendly fire. So friendly fire is really all this third-party garbage that runs in our systems. Friendly fire is the sort of invasive and just unsafe stuff that gets bundled or injected into applications that are running on your machine or device. So I bucket these into 3 main categories. First, you have browser plugins. This is one of the few areas where I might have something positive to say. Not about browser plugins, they're horrible, but positive to say about the current state of affairs. Then we have the OEM value adds. I really don't understand why they call them value adds, because that is the most misleading name in the world. But this is really like the shovelware and the crazy customizations, the ugly things that OEMs do that they just slap on your PCs and devices. And then our other good friendly fire friends are the certificate authorities who do a bang-up job of running the infrastructure that we all rely on. I really appreciate that. And then finally, at some point, I might talk about antivirus and other security products. Although I try to fit that into 140 characters or less. So, why are these things so bad? This comes down to a few different key points. Number one, they totally destroy our security expectations. I mean, I talked before about how different platforms makes it hard. It's one thing when you're dealing with documented APIs and when you're saying, okay, Android does this weird quirky thing, Windows does this weird quirky thing, and Mac does this. Okay, make them all, figure out some way to let them all out, that's fine. But then you have that, you figured that out, you think you're okay, and then it's like a monkey with a chainsaw came in and just tried to break everything up. And it's not just the unexpected behaviors. I mean, if you look at Tavis's work, for example, on antivirus, it's that these things are breaking your expectations on their way to introducing as many vulnerabilities as they can pack into the amount of code they have. It's really kind of a shocking thing, and is no end of pain for my team. The other thing that makes this so bad is that it's completely opaque to the end user.
The end user has no idea that it was their antivirus that's the thing that broke Chrome. They just saw that Chrome broke. They don't know that, the AV that shipped on their machine, or that fun little Superfish utility that, actually probably Superfish didn't do that, but whatever utility the OEM happened to add. We've had cases where the Bluetooth manager was leaking random stuff into sandbox processes. I mean, it doesn't really, there's no rational explanation for most of this, but the user has no idea why it's all breaking. It's just our fault from their perspective. And all this stuff makes triage, diagnosis, any kind of feature planning just a nightmare. And then finally, the thing that I hate is that it's a completely broken incentive structure. So these things actively condition users to very unsafe behavior because they realize that if users don't see it in their face on a regular basis, they don't perceive it as working. I've literally had conversations with people about, well, it's on Twitter, maybe that's not a real conversation, but about antivirus, and they say, well, I tried Microsoft Defender, but I didn't see alerts, so I stopped using it. That's a really pathologically bad behavior. You don't want to be expecting to make security decisions. The truth is that we've done a ton of UX research, there's been a ton of independent UX research on this. What you actually want is to not have the user making security decisions. If they have to, you want it to be as clear, as succinct as possible. And these things are up there in your face, flashing obscure names that make no sense to the user, and just turn them into angry little click monkeys that are just trying to get rid of the alerts. And this carries over into their usage of every piece of software. So, now that I've explained the things that I hate and why, we're going to go through some examples. Now, most of these are the more egregious bad behaviors. Some details have been changed to protect the guilty parties, mostly because I don't want to get sued or fired or anything. But all of these things have actually happened to us. So we're going to start with plugins, specifically NPAPI plugins. Now, NPAPI stands for the Netscape Plugin API, but really it's less an API than it is sort of an organic growth of leaky platform abstractions, most of which spurted out from Windows 3X. And this is something that we carried for well over a decade on browsers because, hey, everybody expected it. So what you actually have is a bundle of purely native code that operates totally outside of the browser's model, doesn't fit our security model, there's a ton of stability and performance nightmares. It's just not nice. So we thought we were going to sandbox this stuff. And we actually tried for a few years. We thought we were really clever. In the end, we realized that we were stupid because you can't just, I guess we learned a lesson. You can't just grab an arbitrary blob of code that does any random thing and say, no, I'm going to put this in a safe box and it's going to be okay. It doesn't work. Functionality breaks, you didn't appreciate the actual security risks, and so you didn't actually fix anything. Maybe you just move the attack surface somewhere else. It's just not a solution. In the end, we realized, you can't bring the code to the sandbox. You really kind of have to bring the two to each other, and make them. It's like that Reddit kiss thing. I don't know, but it's really the only way to make it work. So in 2012, we got to the point where we realized that this is where all of our, for a period there, actually all of our user compromises came from. Like before the days of like the downloads and the phishing, this is how people were getting popped, just running ancient plugins, or just fundamentally broken plugins. So we decided to start blocking the ones that were the biggest targets. Java was everybody's favorite for several years. There were a number of other ones. The user could still run them if they needed to. By default, they didn't run. The thing is, we had to gather a bunch of data when we did this. And what was really useful about gathering that data was when we realized that people weren't really using plugins that much anymore. And these things were on a real steep downward trend. So we could probably just kill them. And my favorite part of my job is killing a feature. Like killing a feature, killing a capability, just ripping something off the web, because it's attack surface that I get to take totally off the table. So we announced our deprecation plan in 2013. It was received interestingly. I became afraid of my inbox because Chrome's an open source project. My email address is in tons of commit logs right next to my name. And my name was on every blog post and every reference to removing NPAPI. So I was pursued with a vengeance by people. My favorite were the ones who pretended to be lawyers. Because there is nothing more entertaining than a grossly misspelled attempt at a cease and desist letter that somebody on the internet emails to you. I actually saved a few of those. I did forward them all to legal because it seemed like the right thing to do. But I got a laugh out of it. I even got bribery offers. None of them were good bribery offers, but I did get offers of bribery, so it was something. But yeah, so eventually the internet worked through its 5 stages of grief, and it was pretty nice. We killed them off publicly in 2015. We still spent over a year ripping out the remaining vestiges of the code because it was such a train wreck. But in 2016, all the code was gone, and then the other browsers actually followed suit. This is sort of, the reason why this is on here is because this is one of my only truly unqualified successes. I had to put a happy one on here just for me. This isn't for you, this one's for me. Because it actually worked and other browsers followed suit. And like these third-party binaries are essentially dead on the web at this point. So I get something to be happy about. It's rare that I get that. Usually I just get to vent my rage. So my next friendly fire is the OEM value adds. In particular, this one was a lot of fun, trying to ship seccomp BPF on Android. Now, seccomp BPF, for those of you who don't know, it's a basic Linux syscall filtering. Will Drury developed it for Chrome OS back in, I don't even remember when. But he worked to upstream it. We carried it for a little while on Chrome OS as a patch. He got it upstreamed in kernel 2.6.12, right? So that meant it sat there for a while. And after a few years, we realized that, hey, wait a second. We might be able to use seccomp BPF on Android. Now that seemed like it would be useful because we weren't really happy with our sandboxing situation on Android. So we decided we were going to give that a try. Now, First, what you do is you probe for basic support. There's a particular syscall that we wanted to use for seccomp BPF to allow us to initiate it in a multi-threaded environment. There's a little bit more complexity going on, but basically we just wanted to probe, see if that syscall was supported. We're not turning it on, we're not shipping anything. It's just a really simple thing where you make a syscall, give it a few parameters that are guaranteed to return an error result that you would expect if that syscall is reported or is supported. We actually have a system on Chrome, which is very nice, that allows us to report this back. You don't have to be too afraid. It's not actually, I don't think you're tricked into using it, or at least the majority of users don't have it turned on, but we still get a very large sampling of Chrome users, and it's statistically representative. It gives us a good sense of what features are actually available and deployed. So, we turned it on, just the probe. And all of a sudden, whole lines of devices from one particular manufacturer all brick. They just start kernel panicking. And now, I'm more of a Windows guy than a Linux guy, but I was under the impression that browsers should not be able to kernel panic Linux. I mean, this is my assumption. And I thought that held. So, we have this crash, we have to deal with it. It is only one OEM. So we get one of those phones, because that's what you do when these things happen. You run out and you buy the affected laptop or the affected phone or whatever. And so it turns out the OEM had hijacked an unused syscall number, which was actually the syscall that we're using. And that kernel panic was actually an exploitable memory corruption. Not just exploitable, like really, really trivially exploitable memory corruption. So that wasn't so great. But the real cherry on top on this one was that their value add was a security feature. And something that they touted in their marketing literature, how great it was. And yeah, so we can't ship a security feature because you shipped a security feature that's not a security feature that it just gets really, really confusing really fast. Now, to their credit, they actually fixed it. And more than fixed it, they actually did eventually ship patches to their users, which is really above the bar, far beyond what we're expecting. So we were fairly impressed there. But still, that's the kind of stuff that you actually have to deal with every day. It's a regular occurrence. So now we get to our next round of friends, the certificate authorities. This is the moment where I would like to actually just have Ryan Sleevey come up and make drunken, angry rants. But instead, I'm going to try to channel him. If you don't know who he is, you really should follow his discussions on the various, like the CAB forum and various mailing lists. It's quite entertaining. He actually doesn't really rant drunkenly. It's quite reasonable but stern. So just a little background. Sorry if everybody already knows this, but it seems necessary. Yeah. The way the CA system works is you have some number of root CAs installed in your operating system. When you go to make an HTTPS connection, the certificate that you get has to chain back to that root CA. There may be some number of intermediary CAs in there. That actually are always some number of intermediary CAs in there. And that's how we establish the validity of the connection. Now, one little important detail here is that because of the way the system works, of course, any CA can sign a cert for any domain. So the system itself has no way of building in tying a certificate to a domain. Or sorry, tying a certificate to a specific CA. Now, that means that the system, of course, depends on every CA being secure. That gets a little scary when you realize that there are effectively thousands of CAs out there. Thousands of CAs because there's actually not that many root CAs, but there are thousands of intermediaries. And any one of them can completely bypass the rest of the CA system because any one of them can assign a cert that essentially says anything. Well, this got us to an interesting point where oddly enough, Sergey Brin, after the Aurora incident, was rather offended at this notion that we have a browser and we have a website, and his understanding was that both were reasonably popular, and yet we have to rely on a CA to enforce the connection between the two. And so he asked why. And we're like, well, I mean, technically we don't actually have to. We can check it ourselves. And he suggested that might be a good idea. So that actually got implemented summer of 2011. It was really hacky. It was something we didn't expect to be necessary, but we threw it in there. It had some bunch of hard-coded values, really ugly UX. It was just a trial. And then August rolled around. And in August, we got a really weird support forum post from someone in Iran. And the guy was seeing the error message, and he was actually quite technically astute. He took screenshots, he pulled the full cert details and everything, bundled it up, zipped it, sent it to us. So we actually had everything. In fact, you can go search for this right now and still find it, because it's still attached to that forum message. But at this point, we're still assuming that, okay, there's just a bug in our code, because 9 times out of 10, it's a bug in our code. It's us. But yeah, it wasn't us. It wasn't our cert. This has actually been signed by a random CA that we'd never heard of, just a tiny little one, and it was a legit certificate as well. So this was DigiNotar. So it turns out that DigiNotar had got popped at some point. Given that they were minting certs that were going to Iran, we assumed that that it was Iranian state sponsored, and they minted actually hundreds of certs for essentially all of the top websites you can think of, and these had actually been out there for like a couple months. Now, this is an interesting situation because DigiNotar was relatively small, and they had committed such an egregious offense that they actually got the CA death penalty. One by one, every major root store untrusted them and ripped them out. So that's a very, very limited win. But the problem is it was another eye-opening event. And the way we looked at CAs fundamentally changed after that. We started monitoring. We realized you couldn't really trust them. And we started monitoring really heavily for misissuance. And what we found out is there's a lot of shenanigans going on. Like every couple months, there's some major issue where the CAs end up misissuing something. We're not talking about the scope of what happened with DigiNotar, but we are regularly seeing certs misissued for properties that aren't owned. So our solution to this has been to push a bunch of things to fix the system. Whole lot of things that we're having varying degrees of success on. Everything's moving forward. Not everything's moving forward at the same speed, but things like shorter issuance periods, HTTP public key pinning, certificate transparency, and it's moving, and we're making progress, but we realize we're probably not making friends right now. But in the end, it's one of those things where you kind of take the hit because it seems necessary. So transitioning off of CAs into antivirus man in the middle, because I'm really here to complain about antivirus. Now the thing is, we're talking about CAs. Well, we regularly actually have to drop support for old crypto protocols because they don't age well. We all know this. It's a reality of security. So take the example of killing an old hash algorithm. You work with standards bodies. You have your discussions. You queue everything up. You try to get everybody aligned. Everything seems good, and then we make an outreach to various major sites, major parties, try to make sure everything's set up, things will be okay. You start the process of rolling it out once you've done all the legwork and everything, and then pow, all of a sudden you get this massive spike in HTTPS errors. So okay, now you have a bunch of clients that your metrics are telling you essentially can't talk to secure sites anymore. So you dig into it, you look, oh great, it's AV. So it's a very common practice in AV. They install a man-in-the-middle cert in the machine, a local proxy. The problem is that that man-in-the-middle cert, in this case, was using an old hashing algorithm. So it was failing, and that meant that you couldn't connect to any secure site. Now, we reach out to them, and this is where it gets weird. Because often the first response is that, oh yeah, we don't know if we have anyone who really is familiar with that. I mean, there are cases where we've been told that, like, oh, that code was written by an intern a few years ago. And I'm thinking, okay, I got a few dozen engineers who are working on security, and then there's a few dozen engineers who are working on our network stack. They're investing all this time trying to make it performant, make it stable, make it secure, etc. And I got knocked down by an intern who left like 2 years ago. This is not fair. This is not the way I want to operate. But eventually you always find someone. Someone antes up, takes ownership of the code, tries to push out a fix. You work with them because this is what you're stuck with. This is what you have to deal with. And yeah, okay. We just start rolling out the fix. And the fix does work. Mostly. But for some odd reason, you've still got an elevated level of errors. And then that's when you learn about the difference between the way they do business and the way we do business, I suppose. Because apparently only paying customers get updates. And those people who are still throwing errors, yeah, they're not paying. And maybe they paid in the past. Maybe it was pirated. You don't know. But they're not getting updates anymore. And if you're not a customer anymore, but you're unlucky enough to have this thing installed, you just got a broken TLS stack. Your browser can't talk to the world. I don't know. My take would be that maybe exit gracefully, shut that thing off. But nah, they're comfortable with that. So the thing is, I just described to you the good guys because they actually, fixed their things and tried to do something. But the baseline here is pretty awful. Like, grossly outdated code. Remember, this was landed by an intern 2 years ago. There's no chance anyone was actually updating any of the code with patches or fixes for anything. This is not the best quality here. And when I say not the best quality, you have to think about basic validation. Because I just told you about a spike in HTTPS errors. The really weird ones are the ones where you have AVs that show 0 HTTPS errors. Like from the AV perspective, they've never seen an invalid cert. Now, I don't know about you, but I don't think I can browse the web without occasionally seeing an invalid cert. I'm not feeling very trusting if you're the bouncer who's just like, no, you're cool, we'll let all you in. But yeah, that's what they're doing. And the thing is that even if we go back to the best behaved products, they're still breaking all of those things that I just talked about that we're trying to do to make the certificate infrastructure better, the things that we're trying to move forward. Because none of that's implemented. That's all at different layers. They don't want to have to touch that. It's too complicated. So yeah, in the end, these are products that are just known and expected to provide grossly inferior security. And now we get to the thing that I actually just really hate the most, which is the binary injections. So I hate this because it eats up way too much of my time. Taking one of the most recent examples. I don't know any of you who are familiar with low-box tokens, but it's a thing Microsoft added in Windows 8. It's extra security primitive that was there for app containers. We have code to use them on Chrome. And we have actually been trying to roll it out. It's nice because it would block the network stack and give us some additional restrictions for our GPU process sandbox. Well, when we try to roll it out in beta, we see spikes in process launch failures. And they're annoying spikes. It's not like, okay, we get the AV, we test it, it works. It's sometimes it launches, sometimes it doesn't. It's flaky, it's weird, it's random. All that we do know is that the metrics correlate to a handful of AV products that have this problem. So we know they're in this bucket. We're not entirely sure why. We're not entirely sure what to do. So now the solution to this is that at this point, I just don't know. I mean, we haven't fixed this one yet. At some point, we're going to get it fixed. Forshaw in the crowd, James Forshaw, he'll be up here presenting later. He's one of the people who I've sneakily roped into helping fix this. It's really frustrating because we have teams working on these features. We plan them out, or, well, in these cases, just, important security measures. And we're constantly getting blocked by these. Like, for injections alone, the only reason why I'm not going into more depth is because I would probably start violently hitting things if I did, because it's such a regular problem for us. And the metrics are just brutal. Like, if you look at this for just delayed security launches, yeah, expect like a year for any sort of new significant mitigation, because that's how long it takes us to work out all of the issues with these third-party AVs and find workarounds. And often the workarounds are things like, well, if you're on Windows 8, you don't get it. Or, well, if you're running this piece of software, you don't get it. I mean, it's things where it's like, basically, we're just peeling these things back until we stop the crashing. And then one thing I hadn't mentioned up to this point is I'm also responsible for the Windows desktop team. And that means that I constantly hear about the general user pain and constantly have developers coming to me trying to understand why their code is literally doing something in the field that is impossible. And then you have to explain to them how binary patching works and how, yes, it's not your code anymore, it's somebody else's code. But I mean, you look at this, and from a user's perspective, crash rates go up 40%. Yeah, they don't blame their AV, they blame us. Memory usage is up 35%. They don't blame AV, they blame us. Well, okay, that one's probably more us. But load time's 20% slower, I'm blaming that one on the AV. And then the TLS stuff, like I said, 15% higher, yeah, that sucks, but 0 is still scarier. And of course, none of this even gets into the whole Tavis thing, which is, this is some of the most trivially insecure software we've ever encountered. I mean, there are times where Tavis has started poking at an AV, and you should just start a stopwatch. I think his record is in like under 30 minutes to go from opening the product to getting root. It should not be that easy. It's not 1999 anymore. I remember when it was this easy. And AV is still that easy. Like, if you want to learn exploits today, start with the soft targets and go with the AVs. So this is why I vent on Twitter. I mean, in the end, it's all this friendly fire junk. It's not just me. It's all of it's my teams. It's all of the people. It's this eats up an inordinate amount of our time. I mean, when I have someone coming to me saying, "Oh yeah, so we're trying to figure out how to get around this AV that's injecting an ancient copy of SpiderMonkey in front of every JavaScript eval." This is a true story. Does happen. Tried to ship profile guided optimizations. Yeah, couldn't ship that because the AV broke. How does the AV break on a compiler setting? Like, that doesn't even make sense to me. Actually, it did make sense. They were monkey patching in just the most childish way. But, I mean, a little bit of diligence here, people. I mean, these things all happen. Like I said earlier, we're talking dozens of security engineers working on these things. We're talking a whole lot more engineering expertise when you talk about like the specific domain areas, like the network and that. When, I mean, I look at what we're expending on trying to work around these problems, and it amazes me because there's no way that AV provider X is investing anywhere near as much in securing themselves from these entry points as I am. And yet they're totally cool just dropping their code right in front of me in the most invasive and painful way possible. So, yeah, this is the problem. It's what I came here to complain about. My take is that they really need to stop doing this, and my expectation is that if it doesn't stop soon, we're going to start looking at, well, frankly, we already have started looking at really creative measures to stop them. And for that, any questions? Because I'd really like to complain more about AV. So somebody asked what creative measures. Yeah, that's where it gets really interesting. So Windows 10 added a number of interesting mitigations for blocking third-party code injection. So we're currently investigating those, and in fact, Edge is currently using some of those for various different reasons, but they even have a blog post about how dramatically their crash rates dropped when they turned this on for Edge, because they just kicked the third-party code out of the process. Now, there's a lot more aggressive stuff that we can do. I mean, you can go all the way down into the kernel and start that arms race if you want to, but that's the extreme case of what we're looking at. Another question.
All right, so I actually have a mic, so if you are one of the few brave souls who would like to ask their question in 3D studio sound, then you can troll legitimately, but quite loudly.
Yeah, hi Justin. You mentioned that you work with standards bodies and you have this problem with AV. So are there any plans to set up standards for injecting code into Chrome so the AV can actually do what they want and you can tell them if they're doing it wrong?
I don't believe in a safe way to inject code. So what I think might be reasonable, and I didn't include this because we're still trying to brainstorm it out, but actually let's take a step back. First, there are APIs that exist today. AVs can, and other security products, can use file system filters. They can get at persistent system objects. The extension system allows them to get in front and do the majority of things they want to do, but in a way that we can identify issues, and if there are problems, blame them or resolve them as needed, and that's fine. The one thing, though, to be entirely honest, is when I look at the trivial vulnerabilities that get exposed, I'm very hesitant to say, oh yeah, sure, let's just give you a pathway in, right? Like even one where it's out of process and contained in that. I mean, what I would really like is a guarantee that AVs are sandboxing their code, a guarantee that they're following some basic security practice, et cetera, that they're just being reasonably good citizens. And right now, I don't see that guarantee, and I don't see any of them really investing any effort in doing something like that. Like a scanning engine, I've sandboxed some pretty rough stuff. A scanning engine really isn't a hard target.
Okay, so does anyone else have a question? All right, over there. I'm gonna get a workout today running around.
Exercise.
Me good. Who was first?
Hi, so are you single-handedly killing Symantec, or is it a group effort? And if it's single-handed, what is your favorite drink?
So, remember that thing about me not getting fired? No, all right, so Symantec is complicated. They're massive. And what I would say is that we are trying to find ways to work with them that benefit the entire ecosystem. And then I'm just not going to talk anymore about that.
Someone else over here?
Is there any chance that you would start implementing security features that would maybe have breakages on certain machines, given that they would be something people would opt into? Like, I want a page heap allocator that doesn't reuse addresses, so that makes me immune to my use after freeze and uninitialized memory bugs. But it's not usable for anyone without 16 gigs of RAM to allocate to Chrome.
Yeah, so there's been a lot of discussion about that. There's been even a discussion of adding special modes for the case of the totally non-tech savvy user, don't allow downloads of executable, of anything executable, that kind of stuff on one end. And then the other of the very tech savvy user of, let me turn the dials and knobs. What I would say is that we do those things only when we see a path to releasing it to all users, or we have some way that we can algorithmically enable it. And that's something that we do on taking different versions of Windows as an example. There's a bevy of mitigations that are available depending on what version you're on, and we try to turn on whatever we can. But in the long run, no, we don't want to add those kinds of custom switches, because for us it's really a game of pushing it out to everybody, essentially trying to set the highest baseline we can, and that's where we're really investing most of our effort.
Is there another brave soul? Okay, so I want to point out a few things before we move to coffee break. Well, first, I want to thank our keynote speaker so much for joining us.
Thank you.
I know that speaking to this kind of audience is one of the braver things you can do as a security lead at a major vendor, and we really appreciate you having the cojones to come out here. But also, I will say that the very first question for all the sessions gets what I like to think of as our modern hacker magazine. So you get a printed copy of POC or Get the Fuck Out. And these are very limited edition, because it turns out it costs about $1 billion to print one, because they're humongous. So if you are the first person to ask the question, then go see Boss Alberts in the back there, and he will give you your, sorry, he's over there, your shirt. I'd also like to point out there is a, it's not a capture the flag, it's a certification that actually means something called the NOP, which this year is being run by the Binary Ninja team, who are both, in fact, binary ninjas themselves. And so if you can solve what I like to think of, simple quiz almost, then you deserve the actual certification. The goal is to set a reasonable bar that is something that you do not have to memorize things for the CISSP. So we're going to pause for coffee break here. And we're going to come back in about 15, 20 minutes and all sit down and have our minds just blown by the next speaker.